In the name of Allah, who is most merciful and most beneficent. Welcome to Dr. Hassan Mathematics channel. Today is my lecture number 3, its second part of ninth class matrices. Some remaining types of matrices is discussed. We will discuss already some types of in the last lecture. Let me start lecture is symmetric matrix. Let A be a scale matrix is symmetric if it is equal to its transpose matrices. A is symmetric if A transpose equal A is called symmetric matrices. For example, A matrix has two rows and two columns. First row is 1 minus 2 and second 3 minus 4. It transpose rows change into column and column change into row. First 1 minus 2 is first row change into column 1 minus 2 and second row is 3 4 change into column. These are not equal to matrices A. A transpose not equal to matrices A. It is not symmetric. And other example is matrices M, 3 rows and 3 columns. Its transpose we take first row change into column 1 2 3 change into column 1 2 3, second row change into column 2 minus 1 4, third row change into column 3 4 3 4 0. These matrices again equal to matrices M. M transpose equal matrices M is a symmetric matrix. Any matrix fulfill these conditions is called a symmetric matrix. Second, skew-symmetric matrix. A square matrix A is said to be a skew-symmetric if A transpose equal minus of A. For example, matrices A 0 2 3 minus 2 0 1 minus 3 minus 1 0. Its transpose rows change into columns. First row change into first column 0 2 3 0 2 3 and second row change into column and third row is change into column. We take out its matrices minus its common. Minus is common from this matrices. 0 is neutral, negative 2 is positive because minus is common. Minus 3 is positive because minus is common. Minus is common or apply. These are equal. A transpose equal minus of A because these matrices equal to again matrices A. 0 2 3 0 2 3 is positive and second row is minus 2 0 1 minus 2 0 1 it's positive and third row is minus 3 minus 1 0 minus 3 minus 1 0. These matrices again equal to matrices A because minus 1 is common. These fulfill condition A transpose equal minus of A. This called a skew-symmetric matrices. Since any matrices these fulfill condition A transpose equal minus of A, therefore is a symmetric matrix. Skew-symmetric matrix. Diagonal matrices. A square matrix A is called a diagonal matrix if at least any one of the entries of its diagonal is not a 0 and non-diagonal entries are must be equal to 0. For example, matrices M, these entries called diagonal entries. Diagonal entries must be at least one equal to at least one entry is not equal to 0. In this matrices M 1 2 3, these are diagonal entries, these are called non-zero and other entries are must be equal to 0 like a 0 0 0 0. These are called diagonal matrices. Second matrix is B. Its diagonal entries 1 2 2 and other is 0. These are called diagonal matrices. Third matrix is its one entries of diagonal is not 0 and other entries are 0. These are called example of diagonal matrices. Scalar matrix. A diagonal matrix is called a scalar matrix if all diagonal entries are same. In diagonal matrices, all diagonal entries are same. These are called scalar matrices and other entries are non-zero. For example, matrices A, its diagonal entries all is same because other is 0. These are called diagonal matrices. Second is 2002, its diagonal entries is 2 2 because these are same. It is a scalar matrix. Third example is C equal to -5. It is a scalar matrix because its diagonal entries is 1 or it is same. Any matrices have diagonal entries are same. These are called scalar matrices. Identity matrices. A diagonal matrix are called identity matrix if all diagonal entries denoted by I. Any diagonal matrix, its diagonal entries denoted by I or 1 is called identity matrices. For example, its matrices A, its diagonal entries I, other is 0 is called identity matrix because is same. Second example is B matrix, its diagonal entries are 1 1. 1 1 show the unity. These are called identity matrices. And other example C, its diagonal entries 1 1, other is 0. These are called identity matrices. Identity matrix, it's these example. Any matrices, these diagonal entries denoted by I are denoted by 1. These are called identity matrices. Thank you. Next we meet in the next lecture.